Welcome, polar bears and polar cubs. Let's talk about solutions. So, some just review of vocab from the videos that we watched. We have solute, the thing being dissolved, solvent, the thing doing the dissolving, and then the solution is the consistency of both. And then we have concentration. So, really, all chapter 12 is us learning about different ways that we can state or identify the concentration of a solution. So the first one that we're going to talk about is molarity. It is capital M equals moles over, this is going to be volume. Now, the volume has to be in liters, and that is of the solution. And N is, of course, moles, and this is of the solute. So it's the amount of what we are dissolving divided by the volume of the entire solution. Now, what you can also do is you can have molarity is equal to grams, again, solute, over the molar mass, also of the solute, times volume, and this would be of the solution. The units for molarity, there's two. So you can either type in mole per liter, or you can simplify it even further and just do capital M. Big M, if you told any chemist, hey, I have 6.5 molar or big M, when you write it out, they would understand exactly what you meant. If I ever asked you to solve for grams, how you rearrange it is, okay, you start with M equals G over MM times V. So you want to get this by itself, so you're going to multiply each side by MM and V. Giving you grams is equal to molarity times volume times molar mass. All right, let's go ahead and do a sample problem. So sample problem number one, it tells you that you want to, what is the molarity of a potassium chloride solution, and if it has a volume of 400 milliliters and contains that many grams of potassium chloride. Well, since we have grams, we're going to need molar mass. So if you take the mass of potassium and the mass of a chloride and you add it together, you're going to get 74.55 grams per mole. And then volume has to go into liters. So you're going to move that decimal 3 places to the front, putting it in front of that 4. So you get 0.400 liters. The equation that we're going to use is molarity equals grams over molar mass and volume. So just plug it in. You get 85.0 divided by 0.400 and 74.55. Giving us a final answer in 3 sig figs of 2.85 mole per liter, and that is of KCl. Great, I'm going to have you guys try the next one. And the answer will be shown to you guys in 3, 2, and 1. So we have a volume of 0.250 liters. You have a molarity of 0.500, and you're asked to solve for grams. So in my mind, I'm going to use the same equation as the first one, and I'm going to solve for G. Well, in order to do that, I need to find the molar mass. So on your calculator, take 1 sodium, 1 oxygen, and 1 hydrogen, add it together, and you're going to get a nice even 40.00 grams per mole. Remember, grams is equal to M times V times MM. So when you plug that in, you have 0.250 times 0.500 times 40. And your final answer. So you're really going to take half of 40 and then take a quarter of that. You're going to get 5.00 grams of NaOH. That is molarity. So there's one more type of concentration we're going to talk about today, and that is going to be percent concentration. Percent concentration is equal to the grams of solute over grams solution times 100. So again, it is just like any other percent. It's the part over the whole. So down here we have, on number 1, we have the grams of solution is equal to 31.26. We have the percentage, and that's all we need to calculate. So what we're going to do is, in our equation, we need to isolate grams of solute. So first thing that we're going to do is divide by 100 on each side, and then we're going to multiply each side by grams of solution. So what it ends up being is grams solute is equal to the percentage over 100, putting it back into decimal form, times grams solution. So that's going to give us 0.0850 times 31.2 or 31.26 grams, giving us a nice total of 266 grams, and the solute is calcium chloride, so that is CaCl2. All right, the last one on here, it tells us on this page, it says calculate the grams of water. Well, remember, solute plus solvent equals solution. So we're trying to find the solvent. So it's really easy. You just take your 31.26 and subtract your 266, giving us a grand total of 28.60. Now, this has to have a decimal place because when you subtract or add, we go the least number of numbers behind the decimal point. Since they don't have a number behind the decimal place, you can only go to the ones place value. Now, here is a problem. You guys can give it a shot. It could be a little bit difficult, but we're going to go through it here in 5, 4, 3, 2, and 1. They give us our percentage, but now they're giving us the grams of solvent. So if you remember, solvent plus solute equals solution. So you have 12.4. That's equal to the percentage. You have grams solution as really this. It's 255 plus, and I'm going to replace grams of solute with X. So when we plug this in, to our equation, what really happens is you have your percentage, you have grams of solute over grams of solution, and you have the 100. So when you divide by 100 on each side, and then we're going to multiply by grams of solution on both sides. So you really get grams solution times percentage over 100 equals grams solute. Well, now we're going to substitute this in, giving us 255 plus x times that percentage over 100 equals x. So when you plug in the rest of your numbers, you're going to get 255 plus x times 0.124 equals x. So distribute the 0.124, giving you 31.62 plus 0.124 x equals x. Put all like terms on the same sides. And then finally divide. Giving us x, which is grams solute, equal to 36.1 grams of NaOH. Right? That has been molarity and grams and percentage concentration by mass. Go ahead and try a worksheet and let me know if you have any